And we are live. So thank you for joining yet another edition of the Ask or Tell live stream. So we have some fun and interesting topics lined up for you today. So we will be talking about Azure Automation in general, and more specifically about infrastructure as code and being able to declare resources in a fast and easy way. So we'll also then talk about Project Bicep, which allows you to actually empower all of those existing deployments as well. So you might have seen that the subtitle of this session is actually Rainbows, Unicorns, and Project Bicep. So we are going to elaborate on that some more later on in this session. So please also stick around for that. For now, let's do a quick round of introductions. So my name is Freek Bersson. I have been working for Vertel for over 12 years now. I'm currently enjoying being in the space of application and desktop delivery technologies. So I work with RDS, VDI, Remote App, Windows Virtual Desktop, and also do a lot of stuff around automation and the Azure cloud. Hence, of course, this session. So I'm not doing that alone tonight. We have a great guest speaker with us. So before I let her introduce herself, she is a true community beast. So not only a Azure MVP, but also Citrix CTP and Parallels VIPP. And I think that she actually also dreams in PowerShell code, but I'll let her comment on that. So with that, Esther, thank you for joining us. And how are you doing?
I'm doing fine, and I'm really excited to share all the Bicep and ARM fun tonight with you. Once again, the magic duo is live and kicking.
Yeah, we were talking about this earlier last week, right? When we were making the fun that it almost seems like a roadshow we're doing, right? Because this is our, I don't know, a third session in the last 3 weeks, and number 4 is already planned. So yeah, glad to have you here. You want to do an additional introduction about yourself?
Yeah, sure. I think you already did a great introduction, but for those of you who do not know me yet, my name is Esther Bartel. I've been an end-user computing consultant for over 20 years. And for the last 5 years, mostly focused on automated deployments, both on-premises and in the cloud, using ARM, JSON, and PowerShell, my favorite scripting language.
Yeah,
and I'm happy to share my knowledge this evening.
Yeah, glad you could be here for this edition as well. So looking forward to it. And also we want to introduce my colleague at Vertel, Maurice, who is actually working behind the scenes to get all of your questions that you are hopefully going to ask and bring them into this session. Maurice, thank you for joining us again. How are you doing?
Yes, great. Thank you. Yeah, thank you, Freek. Yeah, I'm Maurice de Jong. I'm a developer at Vertel. And again, in this show, I will handle the questions to you two as experts. And you can send in your questions using hashtag AskVertel on Twitter, or you can use the chat box here on YouTube. And at the end of the show, we will pick one of the questions or our question makers as the winner of the amazing prize of an Amazon gift card of 50 euros. And this time we have another giveaway, and Esther will reveal the details about that later in this show. So yes, back to you, Freek.
Great. Yeah. So thank you for being here, and let's get started. So this session is entitled "Get Empowered with Project Bicep," and as you can see on the deck right now, Esther did a great job of redoing our slide deck and adding in some fun pictures for the intro. So you're probably going to see them throughout the deck a couple of times. But let's get started and share with you the agenda of what we're going to cover in the next 50 minutes or so. So we'll start with an introduction into automation for the Azure cloud in general. So we'll take a look at the Azure Resource Manager engine, which, as we'll see, is our front door towards all of the resources that we're going to create in the Azure portal. Then we'll take a look at ARM templates and JSON templates. So we'll see some of the power that you can use those templates towards infrastructure as a service and infrastructure as code deployments. And then we'll transition into Project Bicep. So we'll take a look at the architecture, where it is in the overall infra as code landscape. And we're actually going to see some live demos. So yes, we are going to do those demos live. So hopefully the demo gods are with us again. And yeah, we're looking forward to share some of the Bicep stuff later on in this session. For now, Esther, you want to get started with the intro on automation?
Yeah, definitely. So yes, perfect. So we figured before we jump right into the Project Bicep fun, it would be smart to make sure that everyone understands where we're coming from, or basically what is the core behind Project Bicep. So we wanted to do a quick introduction of the Azure Resource Manager, because as you can see, the Azure Resource Manager is the heart of Azure and basically allows you in an automated way to create the resources that you need within Azure. And we can do that not only by directly communicating with Azure Resource Manager itself, but we can also use different scripting languages through the different CLI or PowerShell, SDKs, REST APIs, or even through the GUI as the Azure portal gives us. So there are different multiple ways to use the ARM, the Azure Resource Manager. And we wanted to make sure that you realize that tonight we are not just showing you Project Bicep, but we're also basically promoting the usage of automated deployments through the Azure Resource Manager. Because what you can see is that the Azure Resource Manager itself has different resource providers available to basically create all the resources that are available within Azure, like the compute, networking, and storage resource providers. And this allows us to basically manipulate and create and be innovative with our Azure resources. But of course, we do not just want you to get excited about ARM, but we also wanted to make sure that we give you enough information to help you get started with ARM and JSON. So if we're looking at the definition of an Azure Resource Manager template that we can use to provide ARM with all the information to create our resources, you'll quickly notice that the template mostly consists of JSON. And that's something that we definitely would like you to encourage in diving into some JSON syntax. I will not go over that in this session, but there are some cool recordings out on YouTube and the internet to also get you up to speed with JSON syntax. So diving into the ARM templates. If we're looking at the template format, like we said, it's formatted in JSON, you'll notice that it has some very clear sections, like a parameter section, which allows you to provide input values for your template. Variables that you can use within your template to create shorter paths to your resources, or even concatenate information like the parameters. Functions, if you want to have some specific functionality within your template, and you can define them as separate functions in that template. And of course, the resources, which is that section that basically determines how and what resources are created by the Azure Resource Manager in your Azure subscription. And if you want to make sure that you get some information after the template is being processed, you can also define some output for your template. And that's the information that the Azure Resource Manager will return after it has processed the template. But if we're zooming in a little bit more on how we can build our own ARM template, it can become a little overwhelming, or at least, admitting myself, I felt a bit overwhelmed just looking at these basically templates for the ARM template sections. So don't be too scared, because I discovered that with the right kind of help, you can quickly get started building your own custom ARM templates. And in order to do that, I found a Quickstart guide on Microsoft documentation. And that Quickstart guide has a step-by-step approach on how you can create your own custom ARM template. It tells you to just go into the Azure portal, go to the marketplace, and select the resources that you want to deploy. In this example, it's a WVD host pool that I wanted to create. And just go through all the different tabs and all the information that you need to provide to your Azure Resource Manager so it knows exactly what resources to create for you. But instead of hitting that create button directly, there's also a small link at the bottom of the page saying download a template for automation. And this takes you to a separate download page that allows you to not just download an ARM template, but to download the specific ARM template customized for the resources that you want to create with this information, in this case, a WVD host pool that you want to create. And it also includes a parameters file that has all the information that you previously provided in the text boxes in that parameters file already to be used. So just hit that download button and you should be good to go. But to make sure that you can also understand the formatting of the template and put it into the right context and even maybe tweak some of the settings to your liking, I would also like to encourage you to check out the ARM template reference guide, because it zooms in and gives you not only detailed formatting or sections, example sections, code that you can incorporate in your ARM template, but it also zooms in on each and every object and properties that you can define within your template. So that should make it easy to customize the templates to your own need. And in this example, I'm just showing you how I was able to quickly add the required DNS servers within my VNet settings.
So it's funny, Esther, that you actually mention DNS server as the reference here, because we all know this saying, right? The root cause of the issue is always DNS, even when it's not. But I think that actually, isn't it true that also the number one root cause for any failing Windows Virtual Desktop host pool deployment is actually a misconfigured DNS server? Is that right?
Yes, so this is the moment where I have to admit that when I first tested my ARM template, I panicked because my deployment fails, and I called my one true WVD ninja, Freek, to make sure that I could quickly get to the root cause analysis. So thank you for reminding me for this subtle detail in why I picked this topic in my example.
Yeah, I remember that Microsoft actually shared that they also saw on their backplane that the number one root cause for every failing deployment is actually a missing DNS server. So you're not the only one. So, but it's funny that you reference it here.
Well, thanks for the reminder. And I think it's very important for our audience to realize that as well. We're not blaming DNS. We're just telling you that it might be a root cause for your failing deployment. So going on with all these cool sources of information and to dive into ARM templates, we wanted to make sure that you also know that there's a learning path on Microsoft Learn that will quickly walk you through all the different basic but also advanced options that you have with ARM templates. And to encourage you even more, this is going to be like an ARM promo. To encourage you even more, we also would like to promote the Azure Quickstart templates library, which has almost 1,000 templates pre-built and ready for you to use. And they can start with a simple VM deployment in Azure to deploying an entire WVD environment, as there's even a special WVD Quickstart guide for that. But basically what we're trying to say is that there are multiple different ways to make creating your own ARM template easy. And the cool thing about the Quick Start guide is that it also shows you how you can use the ARM templates for an automated deployment. And of course, this example has my favorite scripting language, PowerShell. So I'm using the PowerShell new AZ resource group deployment commandlet to quickly deploy my ARM template file and the parameters file to make sure that the Azure Resource Manager has all the information it needs to create the resources that I would like to have in Azure. And of course, this was going to be my glory moment where I would show you in a quick demo just how easy it is to use your own custom ARM template for automatic deployments. But unfortunately, as you can see, my deployment failed. So the good news is you do get some cool error messages that will definitely help you to pinpoint that root cause analysis. But I have to admit, in my case, looking at the ARM template that I was already kind of quickly understanding, it wasn't as easy as I was hoping to find my root cause analysis. Because in this example alone, it already had like over 500 lines of code. And I found myself scrolling back and forth between the different sections where references to parameters and variables were in the resource section, and I had to basically backtrace if I made some errors in the parameters input. And to make it even more exciting, there's also advanced options in your ARM templates, like nested templates or even linked templates, which basically makes you dependent of resources outside of your template that could be changed in the meantime. So the conclusion basically was that it's not all rainbows and unicorns.
Yeah, so there's actually a fun fact about the picture that you have on the slide right now. So obviously, Esther and I, we were changing the deck last minute yesterday and the day before, adding in some random rainbow unicorn pictures. And so I added this one in the deck, replacing, I think there was a frowny face smiley or something like that. Adding in this picture of it's not all rainbows. But I only found out yesterday, apparently, this is an actual kid book, which is available on Amazon.com, which is actually called It's Not All Rainbows and Unicorns. So we decided to actually give one away during this session as well. So if you're interested, especially if you have kids in the age between 4 and 7, it's going to be a great book to read to them or with them. If you're interested, leave us a notification in the chat window, and we're going to give one away at the end of the session as well. Just because, you know, it's not all about rainbows and unicorns, right?
Yes, for that you understand that this session is not about bad-mouthing ARM templates. Yes, I did manage to find the root cause, and I do have some cool ARM templates that make my deployments in Azure a lot easier. But still, thinking back about the rainbows and the unicorns, I did call Freek again after the first errors that were shown. And I basically asked him if there might possibly be a smarter way or a better way to make sure that my ARM templates were a bit more robust and a bit less error prone. So I could tell you the cool sales pitch that Freek basically gave me, but I guess this is the moment where I let Freek shine himself and let him tell you the story himself. So back to you, Freek.
Great, thank you. So yeah, we've seen a lot of the stuff in just a matter of minutes. So now, obviously, like Esther said, there's a lot more detail to share about ARM templates and how to author those. But as we mentioned, there's a real power behind ARM templates and doing infrastructure code the way we're doing it right now. So what is Project Bicep and how is that going to further empower your existing deployments? That's what we're going to take a look at right now. So if you're not or less familiar with Project Bicep, what is it? It is a domain-specific language, specifically for the Azure portal. So that means that it allows you to create your resources in a declarative way. So you might be thinking that's exactly how Esther just showed us using ARM and JSON templates. So the number one question we always get is Project Bicep going to replace ARM templates? And the answer is definitely no, it's not. So it is aimed to drastically simplify the way we're authoring ARM templates and ARM deployments today. So it provides a much better, a much cleaner syntax, as we'll see in a demo in just a second. It trims down the number of lines of codes, literally. It allows you to have much better modularity in all of your infrastructure to also reuse parts of your code. So you can think about it as a transparent abstraction layer on top of what we know of ARM and ARM templates today. So let's take a look at a architectural diagram to sort of position where this Project Bicep is in the overall Azure Resource Manager landscape. So we still have that big blue bar that Esther also showed you, the Azure Resource Manager engine, which is still going to be our entry point into resource providers, leading to resources, but also Arc and Kubernetes and GitHub and all of those things. That's not going to change. On top of that, we still have ARM templates. So we still are feeding ARM templates into the ARM engine, creating our resources in a declarative way. Again, that's not going to change. So Bicep is the transparent layer on top of that, which allows you to define these resources, to declare these resources in a Bicep language instead of in the ARM JSON language. So that leads actually to .bicep files. So the extension is actually .bicep. And those files are then transpiled into actually JSON files. That also means that any existing deployment method that you're using today, whether that's PowerShell like Esther does, or DevOps, or inserting these templates directly into template specs, for example, in the Azure portal, that all remains exactly the same. It's only that the creation of the ARM templates can now be done using the Bicep language instead. So as we'll see, it's a much more intuitive way to author these. In the demo, we'll do a couple of side-by-side comparisons as well. And again, it has that modular approach. So you can extract pieces of code, put them into separate Bicep files to reuse them for other projects as well. So the entire thing is open source. So if you visit aka.ms/bicep, you'll be redirected to the GitHub location where Microsoft shares all of the source code of Bicep. You can actually contribute to that as well. So add examples, add your Bicep examples. And in the meantime, I think that Esther showed almost 1,000 ARM templates. Bicep is getting there, hopefully. I think we're around 100 or 200 examples in there as well. But people are now constantly contributing to in that area today. So if you are familiar with ARM and you're doing ARM templates now, and again, whether that's DevOps or PowerShell or ARM templates, that doesn't matter. How can you then transition to start using Project Bicep? How do you go ahead and start installing it? It's two basic, simple steps. So the first step is to actually install the Bicep CLI, which is a requirement. So these lines of code automate the installation for you on your local machine. So full disclosure, I did not come up with these PowerShell lines. These are just available on the docs pages on the GitHub. But that's the first step. And then the second step is an optional step, which allows you to install the VS Code extension, which gives you things like IntelliSense and tab completion from within your editor to fully get that optimized authoring experience. So although it is optional, we can really encourage you to start installing it as well, because it brings you the full Bicep authoring experience.
Makes it even easier to create your ARM templates.
Yes, definitely. So again, we have a great slide added by Esther. I think it was yesterday, introducing
Yes,
the
I'm
ARM
guilty
demo.
as charged.
Guilty as charged. But without further ado, let's dive into a live demo. So let me open up VS Code. And as you can see, I have the installation, the same installation steps already here, which I already ran, which allows me to install and have it available in my VS Code editor. And I just did a Bicep -- version, which allows me to retrieve the current version of Bicep. So currently it's a 0.2414 version, which is currently a preview version, but we'll dive into what that means at the end of the session as well. We'll take a look at where Bicep is today, what to expect, and when this goes to the next release. But the optional other way I quickly want to show you, if you go to the extensions and you search for Bicep, actually it is already here, you can also download the extension right here from the marketplace inside VS Code. So let's go ahead and start creating our first Bicep file. So I have an existing Bicep file here called main.bicep, which is empty. But it is actually a valid Bicep file, although it doesn't contain any source code. So let's take a look at what happens if I actually transpile this file into JSON. So what we do is we enter bicep build and then the name of the Bicep file. Hit enter, and we get presented with the JSON equivalent of an empty file. So guess what's going to be inside that JSON file? Not an empty file, but actually the skeleton of our first JSON deployment. So similar to the one that Esther just showed you in the deck, this is actually a valid JSON file. I could go ahead and deploy this into the Azure portal. It wouldn't create anything because we didn't define any resources, but it's a valid skeleton for a first file. So
yeah, no errors is what you mean, Freek.
No errors, yes. So let's now go ahead and create and declare our first resource into Bicep to see what that experience is like. So what we do is we type resource, and then we give it a name. So in this case, we're going to create a storage account. So we'll do stg, and then type storage account. As you can see, I already have this IntelliSense going on with all of the types that are available, including the API versions. So let's select the latest preview version, an equal sign, and the brackets. Oh, not these brackets, but these brackets. So the first thing you'll notice is that the declaration of this resource type, including the API version, are now already a single string. This is something that in ARM was already two separate strings, right? So let's now do the IntelliSense, and it shows me the list of mandatory properties for the creation of this storage account. So let's give it, in this case, a name. And let's do Ortel. And we also know that we need to give it a kind of storage account. So let's do a blob storage. And let's provide a location and make that East US. That's for this demo. And I also know, because of this IntelliSense, that I need to provide a SKU, which is actually multiple properties. So let's at least provide the mandatory one, which is the name, which is Premium LRS. And that's it. We have now declared our storage account of kind blob storage of SKU Premium LRS, ready to be able to deploy that in the Azure portal. So let's save this and do that transpilation again. And let's actually open it up side by side now. So as you can see, we can already see the much more cleaner syntax on the left-hand side versus the JSON equivalent on the right-hand side, right? There's a lot of brackets and stuff going on, and we went from 8 lines of code towards 17. So just to be fair, a lot of the IntelliSense and a lot of the tab completion is also available for ARM templates themselves. There are also extensions available that help you with that. But JSON and ARM authoring experience doesn't have, and what Bicep does have, it allows me to refer to properties of a previously declared object. So let me give you an example. So if I want to create an output for this JSON file, and let's give it a name stg out, it is going to be a string, and it's going to be equal to stg. And as you can see, stg is now a reference to the previously declared resource, which is our storage account. So now we can say properties, primary endpoints, and for example, blob. So we're now outputting the generated blob of the primary endpoints of the properties of the storage account, simply by having that IntelliSense available. So let's go ahead and recompile that file again, or transpile it. You can already see the difference and the easiness of how to declare such an output parameter by simply using that tab, IntelliSense completion, versus on the right-hand side, if you would author this directly into JSON, you would have to know that you have to use the reference function and then incorporate the resource ID function and then concatenate some static values with parameters and all of the magic that's going on in this line. So just to give you an example again of the authoring experience as well as the readability of the left-hand side and right-hand side.
Yes, this brings back some nightmares on scrolling through all the ARM code.
Yeah, sorry about that.
Can I interrupt Maurice, for a second, guys?
Yeah, sure.
Yeah, definitely.
Okay, great. Yeah, I have a question. There is a question related to this content you were demoing. You showed the JSON file, so the ARM template as well. And IceBlockje has a question about it. Let me show it on the screen. He asks, what are the functions used for in the JSON template? So there's a little section for functions I saw. So I thought, okay, this question is really related. So let me interrupt you.
Yeah, so if we go back to a couple of slides that I focused on the default template of an ARM template, you'll notice that it has a function section, and that is for your own usage to add your own internal template functions in there. So that could be mathematical functions or the concatenation that you want to provide in a standard function that you want to reuse in your templates. So that's where the function section is for. Okay, I hope that answers the question.
Well, we'll see. Okay. I think so. It answers my question, because when I saw it, I said, wow, that's what he was asking about. And then
I have to admit. Sorry, go ahead.
No, go ahead.
No, I was going to say, I have to admit that I haven't used that section myself a lot in ARM templates, because I'm usually focused on the variables and the parameters and making sure that I get the resources in place. So that's probably why I really skipped over it very fast in the beginning.
All right. Well, yeah, there's another question from Frank van Diest. It's a little bit of a tease, but he asks, will they be learning about ARM in that book as well?
That's a great question. I would be surprised if they would, but I don't know. If you sign up and make sure you win, you'll probably find out. But that's a great question.
Okay.
Right.
And so let's continue. Another question from.
Go ahead.
Can I send one more?
Yeah, go ahead.
Yeah, sure. There's another one from Twan. Is Biceps CLI also available for PowerShell on Mac OS?
Yes.
I would not know. Do you know, Esther?
I'm going to say yes, but I'm not entirely sure, to be honest.
Right.
But I do know that when you install PowerShell, the Biceps CLI, it is included, or you can call it from your PowerShell core. So that's why I hesitantly said, yeah, sure, it's usable within PowerShell core. So go ahead and test it on the Mac.
Yeah. It's probably there, and if not, I think the best place to get started is that aka.ms/bicep. That is actually the GitHub where you can find the installations and maybe for other operating system and other purposes as well. But we probably think that it is, but it might be the best spot to double check there.
Yes, so I might just frantically Google it right now and get back to you after the demos.
Let's do that. So let me continue the demo. So the one thing I wanted to show you inside this bicep file is also the creation of parameters, right? That's something that Azure covered in the first section. So we simply start adding that parameter by typing param, and then give it a name, for example, stg name, which is going to be a string. And that's also provided with a default value similar to the one we just declared inside the actual resource. And now we have a first parameter which we can replace for the name right here. So now if I would transpile this, you can also see the difference in declaring parameters, which in Bicep is a single line, including the default value here, versus the one on the right-hand side with all of the brackets and all of the commas, etc. going on. So just to give you a first example of the authoring experience, Bicep versus JSON, and how they transpile into an actual JSON template. So let's step up our game and take a look at another example, which is a VNet. And I already prepared this one, so not that I have to type this live during the session. But as you guessed it, probably this is going to create a VNet inside the Azure portal, including in this case a couple of subnets. But just to also show you the easy way of concatenating values together by simply having two single quotes and then a static value followed by a reference to, in this case, the DNS suffix, right? Super easy compared to how you would do that with all of the functions inside a JSON template. So let's take a look at another example where we are creating multiple objects in one single Bicep file. So looking at the name, you probably guessed that this is going to create a, open the wrong file. This is going to create a virtual machine, right? The VM Bicep file. So again, we have a couple of parameters. In this case, we are also setting a couple of variables. So we're concatenating a couple of things here. But let me take you through the resources we're creating here. So we are creating a VNet. Again, we are creating a network adapter, and we are declaring a virtual machine. So if you are familiar with ways to deploy such resources towards the Azure portal, you probably know that we, as the author, need to tell the ARM engine which object to create first, right? So because I cannot create a virtual machine without having a network adapter, and I cannot create a network adapter without having a subnet and VNet in order for it to point to it. So let me show you how that's done in Bicep versus I would do that inside JSON. So again, we're going to do a build, and this time it's going to be example number 4. So we just transpiled this JSON into Bicep into a JSON file, and again, let's open it up side by side. So we have 94 lines of code here. We already went to 125. But the thing I wanted to show you is those multiple objects and how they relate together using those dependencies. So let's take the network interface as the example. So on the right-hand side, we have the declaration of the network interface in JSON. And as you can see, I have a depends on section here. And this allows me to specify the resource that needs to be created first prior to this resource being created. So in this case, I have I'm pointing to the resource ID of the virtual network with the parameter of the VNet name. What you'll notice on the left-hand side is I nowhere in this declaration made an explicit depends on. So how does the JSON, how did the depends on section end up in the JSON template? How did the transpile engine know why to do that? The reason is that I'm pointing to a property of a previously declared resource here. So I have a VNet here, and at this point, I'm pointing to the ID of the VNet, and that VNet is actually the resource we created above here. So simply by providing or pointing to a property of a previously declared resource, the Bicep transpilation knows to add that depends on section automatically for you. So it's called an implicit depends on section. So it's going to save you a lot of trouble if you have multiple objects and didn't define the order or defined the incorrect order. This will be a lifesaver. So that raises the question.
Especially if you're trying to troubleshoot your ARM template. Because for those of you who paid attention at the error message I got previously, it was specifically exactly pointing towards the dependencies. Yes.
Yes. Yeah. Yeah, it's a very common thing to have because you as the author need to be aware of which objects need to be created first. So you need to investigate that and get those depends on sections in there. So it's always a trouble to have the correct amount of dependencies, not too much, not too little, but the exact amount. But yeah, the Bicep transpilation makes that for you. So that does raise the question, can I also still do explicit depends on? And the answer is yes. So I still have that explicit depends on section here, allowing me to explicitly define any depends on sections, maybe for resources where I'm not referring to a property of that resource, right? So you can still do that. Just to give you another example of the power of that transpilation towards JSON. So let's again step up our game and take a look at modules. So we did cover the modularity in the slide deck as some of the new features of Bicep, the ability to extract pieces of code into separate modules and have them available for reuse, right? So on the left-hand side, I have example number 6 in this case, which has a 6 main.bicep, which we'll cover in just a second. But we have a 6.1, 6.2, 3, 4, 5, etc. So all of these files are just Bicep files. There's nothing special about them, although they have the name module inside the file name. That doesn't do anything. And there's nothing that you as an author need to do in order to make a Bicep file an actual module file. So let me take you through an example. For example, the network again. So we already saw this demo. We already saw this example in the previous demo, the declaration of a VNet with a couple of subnets. So as you can notice, there's nothing different about this Bicep file. It also has a lot of parameters. It also has the declaration of the different resources. So in this case, I'm creating a VNet. And I'm also creating a peer-to-peer towards my Active Directory to do AD communication. And also in this case, creating a template VM as part of this Bicep file as well. So this is just another Bicep file. I could simply transpile this single file into a single JSON file. The same thing applies to all of the other examples here. So let me give you another example of what we're creating. For example, the image gallery. If you're familiar with this is a preview object in the Azure portal right now, which allows you to define template images and the automated creation of those. And again, we are using parameters. We are defining resources. So for example, the image gallery, a couple of role definitions, a couple of image definitions, etc. Again, nothing special about these Bicep files. So how do we then bring all these Bicep files together into a single file? Let's take a look at that. So let me open the main.bicep and show you how that is done. So again, I start with the declaration of a couple of parameters. So in this case, I'm collecting basically all of the parameters that I need for all of the objects and all of the modules, as we'll see in a second, that we're calling from this file. But the first thing I do, and this is important if you are doing bigger deployments than in single resource group, is I'm changing the target scope towards subscription level. So this means that usually when you do a deployment of an ARM template, you usually have one or more ARM templates that deploy into a single resource group. But in this case, we are deploying, you might have guessed it based on the naming convention, a Windows virtual desktop deployment that consists of virtual machines and WVD backplane components and networks and image definitions and file services and key vaults and that. So we are also creating all of those resources groups from within this Bicep file. So let me show you. So let's scroll down to where we are actually defining the resources. So right here, we are creating all of those resource groups. So we have one for our networking, for our template images, for our backplane components, etc. So you can see that I do a concatenation here with a prefix and a postfix in order to get the right name for that resource group. Then what I do is I, again, create a couple of resources. So this is not different than the way we did it before. This is resources that are actually created by this Bicep file. So let's scroll down to the first module, which is this one. So instead of providing the resource keyword, I'm now providing the module keyword followed by a name and then pointing to the specific Bicep file that has the declaration of these objects. In this case, the backplane for my Windows virtual desktop deployment. Then what I do, I specify the scope. So I specify in which resource group those objects need to be created. So in this case, I can refer to, again, an object that I previously declared. And I am passing all of the parameters that I needed for this bicep file to complete. So the rest of this main bicep file contains me calling modules that are inside other files, right? So this means that I can create a new main bicep file pointing to a subset of all of these different modules. So that's the way the modularity works in a high-level overview, I would say. So let's go ahead and start transpiling this file.
Freek, just a quick question.
Yes. Sure.
Can I easily reference the definitions in one module file from the main file where you have all these modules come together? Because
That's
what you showed is that if you create those different resources, that in the next one you can reference it. And I was wondering, if you create it in separate modules files, can you still reference to a different module file resources?
Yeah, that's a great question. Yeah, so you're right. So the examples I showed you were all referring to resources created inside the same bicep file. And I actually will be able to show you that if we take a look at this example here. So here we are. It seems like we are creating a resource here, which is the host pool that we've seen before in other examples. But notice that we have the keyword existing here, followed by an equal sign and a name of a host pool. So these lines of code, because of the keyword existing here, they do not actually create the resource, but check if that resource exists and grab the name of that resource, in this case, the host pool name. So now what I'm able to do in the declaration of an actual resource we are creating, I'm able to specify the host pool, which refers to a resource which was not created inside this bicep file. So that's the way you do that with the existing keyword. So full disclosure, this is actually not available in the current version of Bicep. So we are cheating a little bit, because I showed you that the Bicep version, let me do that again, is this is not the actual version that is out there to the public. Well, it is, but in a more decryptive way. So this is not the current stable version. So we're actually working on the nightly build, as they call it, from Project Bicep, which already contains this existing feature. So this is coming to the 0.3 release, which we'll cover in the deck later on, as one of the new features to use it. But definitely a great one, like you said, to be able to point to resources that were created outside of your existing Bicep file.
Awesome, thanks.
Okay. So let's go ahead and create these resources, and then let's take a look at some questions while that deployment is running. So let's first deploy those virtual machines, right? So we had that VM Bicep demo, again, if you remember, that creates the VNet, the subnet, and the network adapter and the virtual machine. So we're going to use that easy resource group deployment here, and we're going to pass the resource group name and provide the actual JSON file. So not the Bicep file, but the transpiled JSON file for the virtual machine. So let's go ahead and do that. And I actually need to provide a local admin name and a password. I'm not going to remember it, so it doesn't really matter what the password is. But let me open up the Azure portal. And I need to be quick, but it's because it will probably finish very soon. And open up this resource group here. And as you can see, it is deploying as we speak. So it already went ahead and created that VNet for us. It already created that network adapter. And right now it's creating the virtual machines. So just to show you that the end result of that transpilation is just another JSON file. And you can use your existing methods to deploy those to the Azure portal. So this is going to finish in a couple of seconds. It's going to complete, and the virtual machine is going to be ready for use. So let me deploy the big main file so that we have some time in between to actually answer a couple of questions. Are there any questions we can bring up, Maurice?
Yes, Freek. We have a question from Seth Daman. His question is, how about, no, how does Biceps compare to Terraform?
That's a great question, and we get that question a lot, I can tell you. First of all, it's not Microsoft's intention to replace or compete with Terraform or any other creation of JSON templates. Not at all. In fact, Microsoft is also constantly improving the authoring experience for Terraform creations as well. But from the Microsoft side, they have done some investigation, and it seemed that of all of the deployments that are done in the Azure portal, 70% is done using JSON templates. So they realized that, and obviously they also got the complaints about the complexity about JSON and all of the syntax and all of that. So they decided to have that transparent layer on top of the JSON templates. So it's not going to compete with Terraform. These are just going to be there side by side. So if you are a big fan of Terraform, there's nothing stopping you from doing that. It's just that's a different approach towards the actual creation.
Yes, one thing that you can take into account is the fact that with Project Bicep, you have 0-day support for any new resources or additions to ARM templates, because those are developed simultaneously. And I'm pretty sure that some of the die-hard Terraform fans have already discovered, Terraform is still dependent on the Azure ARM provider. So it will probably take a little bit longer before those latest and greatest features from ARM templates are incorporated in the Azure ARM provider for Terraform. But if you have time and you feel more comfortable using Terraform, we definitely do not want you to get discouraged and force another language on you. It's all about choice with DevOps.
Yeah, cool. I agree. So let's... yeah, go ahead.
No, there are more questions.
Keep them coming.
Bring them on.
Okay. This one is from Michiel Dekker, and he asks if you can decompile from existing JSON files into Bicep.
That's a great question, and the answer we'll find out in about 5 minutes from now. So stick around for that.
Okay.
I would say.
Okay. Well.
Yeah. No spoilers.
No spoilers.
Okay. Then I have another question from IJsblokje. His question is, when you link to another Bicep module, does that module or file need to be placed in the same folder, or can it also be a remote file?
That's a great question. Yeah. So for now, for the transpile process, it needs to be on the local machine. But obviously, you can imagine that in the future, similar ways of grabbing files online or referencing them to a public GitHub location, for example, is also possible. But for now, it needs to be on the local system somewhere. It doesn't necessarily have to be in the same folder, but it needs to be available as a Bicep file locally.
Okay, cool.
All right.
Oh, okay. Go ahead.
So
that's
yes,
it for this.
Yeah, I was waiting for
problem.
the next question. But...
Yeah. So in the meantime, this deployment actually finished, so we can see the successful deployment on the screen right now. So if we would transition back to the VS Code, it is also finished, and the resource, in this case, the virtual machine, is created. Now, this obviously wasn't really a spectacular deployment, right? A single virtual machine in Azure. Let's now create the JSON file for the 6 main file. So let's do a bicep build and then example number 6, the main.bicep file. So again, we end up with a 6 JSON file. No surprises there, but take a look at the number of lines of code that are in here. So there's over 2,000 lines of JSON code here. So why did that happen? Because if we take a look at the original bicep file itself, that is only 300 lines. So how did that happen? What the transpilation process does, if you call a module from, in this case, a main.bicep file, it will also incorporate all of the modules that you are referring to into a single file. And that's the reason why we end up with such a huge JSON file. So this is actually ready to deploy, and without further ado, let's go ahead and do that. So in this case, we're going to use the new AZ deployment commandlet and pointing it to the 6 JSON file with, in this case, also a parameter file, including some parameters that we're overriding to this deployment as well. And let's go ahead and deploy that. So now it will take this huge 2,000 line plus JSON file and cram it into the ARM engine to be able to deploy that, all of the resources that were declared in here. So remember the resource groups and all of the WVD deployments and the virtual machines, etc. They are now being created in the Azure portal. So let's go ahead and take a look. And let's go back to the resource groups and search for Bicep and refresh here. And as you can see, already a lot of resource groups have been created in just these couple of seconds. So taking a look at, for example, the Windows Virtual Desktop resource group, we have a couple of resources created here. So if you're familiar with these are host pools, application groups, and workspaces that are needed for a typical WVD deployment. But we also have file services being created. So I have 2 storage accounts here. One of them is specifically for the Azure Image Builder process we covered as well, which contains actually 2 prepared containers for my Azure Image Builder scripts and my software. But we also have a resource group for monitoring here, which contains our log analytics workspace, and all the objects are now already also pointing to this workspace as well. We have VNets being created with subnets for our production and also acceptance environment. And as another example, we have a fully working Azure Image Builder process here available as well, including all of the objects that we need. So let me group those by type. We have, if you're familiar with these, the Azure Image Galleries, a managed identity that's needed, image version, image templates, all ready to go and start deploying our first WVD host pool. So these were all created by a single Bicep file in a matter of seconds and without us touching any JSON code. So let's switch back to the VS Code. It should probably finish in a couple of seconds. It's probably now deploying the template VMs that are also part of this deployment. But just to show you that the modularity approach of Project Bicep is really a key concept here, allowing you to extract pieces of code from the Bicep, from the overall Bicep file, and reuse those for other projects or other deployments as well. So that's the main deployment. And taking a look at the time, we should probably head back to our slide deck because we have some more information to
you
share.
still have to answer one question, Freek.
I do?
There was a question about decompiling ARM templates.
Yes, thank you for reminding me. So, and in the meantime, actually, this deployment finished. So thank you for taking up that time. But the deployment is now finished successfully. So we can now have the terminal back and actually show you the decompile process. So I have a file here, example number 8, which is called to decompile. So it happens to be here. So let's do that. And that's called Bicep, and simply say, you probably guessed it, decompile, and then the name of the JSON file. Now what the engine does, and it actually warns you because this is currently a preview process, that this is done at a best effort process. So the decompilation is there, but it's not 100% complete yet. So, but it is actually there. So right now I have a 8.bicep file, which again leads me to the resources that were declared in the JSON file. So to answer those questions, yes, you can definitely do that. And probably the reason that he asked is because you can have a lot of JSON examples, right? The 900 plus that Esther showed you, you would be able to download those from JSON, decompile them back to Bicep, and then start reusing them as new Bicep files as well. So hopefully, and probably that answers the question about decompiling.
Definitely.
All right. So let me now, for real, switch back to the slide deck so we can do a couple of things we wanted to share before we let you go. And the thing is, we wanted to share with you is a roadmap, right? So we discussed the version that Bicep is into right now. So I showed you the 0.2414 version that I'm running, which is the nightly build, which is a pre-build of what's coming. But the current stable release is the 3.8 version, which contains these properties as shown in the deck right here. So where we're coming from is a .1 version, which was released in August last year. And as you can see, it's from there started rolling really fast. And we are all anxiously waiting for the .3 version. And Esther, you probably know that we are all waiting for that single one feature that is not implemented into Bicep today, which is the loops, right?
Yes, definitely. So yeah, I for one am dying to get my hands on the .3 version, because especially with the WVD deployments and deploying variable numbers of session hosts, those loops will definitely be a lifesaver.
Yeah, for sure. Yeah. So we already seen some from pre-releases of that, and the estimate is that somewhere this month or early March, the latest, that .3 version is available. That also means that from that moment on, it's ready for production use. So you might be wondering what that means. That means two things. First of all, anything that you create using a Bicep file, so the end result, the JSON file itself, that's 100% compatible and 100% deployable for production environments. That's not going to change. What is going to change is a couple of syntax things inside the current version, the .2 version, which will change towards the .3 version itself. So it's only a couple of syntax things inside the Bicep file. So anything that you create from Bicep, that JSON file, that's 100% production ready. So right now they are at 90% feature comparing to ARM templates itself, which is pretty impressive. If you know, they only started last August. But there are a couple of things that are going to change. And I think, Esther, you wanted to talk about those some more, some of the breaking changes that are coming in the 0.3 version, right?
Yeah, definitely. So we wanted to zoom in on two of the major breaking changes that are planned for the 0.3 release. So the first one is the parameter decorators. And I have to admit, at first I didn't fully understand decorators because I'm not a developer. So that's one of the reasons why I still call myself a scripter. But the cool thing about the decorators is, especially if we're looking at loops within ARM templates, is that loops have different modes. They can either do a serial or a parallel loop. And you can now use those decorators to specify which type of loop needs to be supported or needs to be used. And as you see in the example in the slide, in this case, it also allows us to already pre-specify the allowed values for a parameter. So that makes our code even more intuitive and better readable by using these decorators. So I'm looking forward to using those and adding that new syntax to my Bicep files. The other big one is the output. Currently, you cannot use the same variable name when you declare an output, even though you are referencing a parameter that you previously used in most cases, or a resource that you predefined. Right now, as you also showed, as Freek also showed in the example, he was using a different name for the output parameter or the output object, and referencing a resource object. What they will now allow, or what they will change in the Bicep syntax, is that you will be able to reuse that same object because it's using the same global space as an output. So now you do not have to basically create like a dummy output object to reference an existing parameter object or resource object. So those are both very cool breaking changes that we definitely wanted to make sure that you are aware of what is coming very quickly to a website near you. And that basically brings us to almost the last slide, because while Freek was showing the demo, I added a few more slides to the deck.
Oh no.
So he's just seeing them now. So what we wanted to make sure, and Freek already mentioned the URL a couple of times, but the reason why we wanted to do this call to action is because this is really a community project. So if you feel there are some components missing in Bicep, or if you feel that some of the syntaxes are not as intuitive, or maybe you even discovered a bug in the current release, feel free to go to GitHub to report an issue, or to even submit some pull requests to further improve the Bicep code. So that's a very important URL for you to take action on. And of course, we wanted to make sure that you also realize that the installation guides, tutorials, and example codes are right there at GitHub. So normally we would switch to the thank you slide, but I'm just going to skip ahead, because what I did is I went to the URL while Freek was doing the demo to make sure that I double checked if indeed the Bicep CLI is installable on macOS. So here's the answer for the question that was asked earlier. Yes, indeed. And you even have two options to install the Bicep CLI, either via Homebrew or you can do a manual install. And for those of you who are using Windows OS, of course, they kind of made it easy for us to just download the Windows installer. But that's just a quick, just making sure that we get all the answers to the questions that you have live as we do the presentation. And if there still are questions that are not answered yet, we'll make sure to get back to you and provide you with the answers as much as we can.
Yeah,
so I
thank you
guess
for
that's
adding
it
that.
for us.
Thank you for adding that on the fly just now, Esther. That's super great.
Yeah,
So before we let everyone
I missed the rainbow.
go,
Sorry.
yeah, that's okay. Before we let everyone go, I think we have some winners to announce. Is that right, Maurice?
Yeah, that's correct. That's some great effort, Esther. Wow, cool. That's some really live demoing. Okay, yeah. We have a winner of today's the best questioner. That's Michiel Dekker. So Michiel Dekker, can you please send a message to werken@wortel so we can make sure you get your prize of the €50 Amazon gift card. And yeah, there was someone else, Seth Damen. He asked if he could get the book. So
Awesome.
that's
great.
our second winner of today. Yeah. And I want to remind everyone, if you are watching the recording of this show, you can still send in your questions using the hashtag AskWortel on Twitter, or find us on LinkedIn and get in touch with us. The goal is to share knowledge to the community. And yeah, just like that, Wortel has joined forces with Intercept to set up an event like Azure Live. And I think Freek is going to tell us something more about that.
Yeah, so we want to make a quick introduction into what's called Azure Live, which is, I think, released yesterday, if I'm correctly. So I would highly encourage you, if you like this content and are looking for more content around Azure in general, go visit azurelive.nl. I'm sharing the webpage on my screen right now. which is a new upcoming event that is going to be hosted April 13th. I do hope that it's not Friday the 13th, but we'll find out. But it's going to be a great event full of Azure fun, as we have seen today. So it also has a call for speakers open. So if you are that community member that would like to share your knowledge or your community projects or your efforts, feel free to also apply for that call of speakers. We're, of course, actively looking for people who are enthusiastic and want to share their knowledge as well. So with that, I think we are at the end of this webinar. So we hope that you enjoyed this content, that it was valuable to you. And again, if you have additional questions, feel free to reach out using those social channels or directly to Esther and me. And Esther, thank you for being here and for co-presenting this with me. And Maurice, great job on the questions and bringing those in live. And of course, I want to do a quick thank you to Jeroen Niesen, who you have not seen today, but he's actively working in the background as our very professional producer who is making this live broadcast available for everyone. So thank you to him. And we hope to welcome you again in the next episode of the Ask Wortel live stream. Thank you.